How many times bigger? Using scientific notation. So these sometimes can look daunting because of the numbers that are being used. But if you think about the process that you have in your other problems that you've done like this, and I'm thinking scale factor because that's where I've used how many times bigger. And that will help us figure this problem out and make it easier. And those that we've practiced have been easier numbers. So we'll use that to help us kind of figure out the process, and then we'll just put our bigger numbers in there. So let's read our question here. How many times greater is the diameter of the sun than the diameter of the earth? Now, that's pretty big. And a lot of people say, big. It's a lot. But we want to, in math, we want to figure out more specifically how many times bigger. So I'm thinking, I'm going to read it again. How many times greater is the diameter of the sun than the diameter of the earth? How many times bigger is the sun than the earth? So that kind of tells me that I'm going to be going this way, and it's going to be a times number. And that this is what reminds me, and that's why I like to use the arrow for scale factor, because that was that scale factor of a fraction. Now I have to put one of these on top and one on the bottom, and I can't tell with these bigger numbers. So what I like to do is make these numbers easier. So I like this one looks close like 14. So let's just pretend that it was 14. It's not 14, but let's just say the sun was 14 kilometers wide. Over here, the sun, well, 1.2 isn't like a nice number. Well, let's make it nice like 2. What if it was 2 kilometers wide and the sun was 14? How many times bigger was that? We probably already know it's 7, but it's not so much getting that answer, but how did you get it? Well, remember we have to use our fractions, so we took and put our 14 on top, divided by 2 to get that 7, that times 7 bigger. So what that kind of tells me is that the 14 was on the sun side, so I'm going to put the sun number on top over the earth number. So now that I have my kind of thinking here, I'm just going to use that times fraction bar here. Now, times, I got my earth number, 1.28 times 10 to the 4th power kilometers. And now I need the sun one. And this one, it doesn't match that one. But I could put it in scientific notation very easily. So my decimal's here, so I'm going to put 3, 6. So the diameter of the sun is 1.4 times 10 to the 6th power, positive because it's a big number, kilometers. So I'll put that one on top. 1.4 times 10 to the 6th power kilometers. Now, you notice what happens in our fraction, kilometers over kilometers cancels out. Now, in scientific notation, you know what? I'm going to get rid of this 14 because I don't need them anymore because I already used the thinking. They're kind of getting a little way in my way here. So now I'm going to kind of solve this and simplify it down now. So I'm thinking, hey, I like my scientific notation on the top, so I'm going to move this one up. So that's going to be 1.4 over 1.28 times 10 to the 6th times 10 to the... Now remember, when we moved a number from the denominator to the numerator or move it to the other part of the fraction, the sign of our exponent changes. So it was a positive, so now it's a negative exponent. All right, so now, what can I do next? Oh, well, I can add my exponents here. So times 10 to the, okay, 6 minus 4 is 2. Oh, so it's just 10 to the 2 power, which is kind of nice. And, oh, I don't so much like fractions with my decimals, or decimals with my fractions, so I'm going to move those decimals to make nicer numbers. So let's see, the top one I have to multiply by 10, and the bottom by 100. So I have to multiply by the same number, so I'm going to multiply by 100, and it has to be the same for the top and bottom of a fraction. So that means I'm going to move this decimal for the top 1, 2, and I need to fill a 0 in that placeholder of that place value. So 140 over 128. Now, that is not the nicest number. So what I'm going to do is I think I'm going to need a little bit more space for simplifying my fraction. So 128. So I'm thinking, well, they're both even, so I'm going to divide by 2 first, because I don't know any bigger number. It probably is one, but I don't see it right off the top of my head. So half of 14 is 7, so half of 140 is 70. Half of 12 is 60. Half of 8 is 4. Oh, and there's another 2. So I can take half of 70 is 35, and half of 64 is 32. Well, that's not so nice. I don't see any other one. So being that this is scientific notation, I'm going to have to go to long division. And it looks like I'm going to need some space. So we'll just get it set up. 32 is on the outside of the house. 35 goes inside the house. Put in my decimal. 32 goes into 35 once. Subtract 32 from that. So 3, bring down the 0. Ooh, 32 does not go into 30, so it goes in 0 times. 0 times 30 is 0. Subtract that away is 30. Don't forget to put that 0 on the top. That sometimes is missed. So 32 goes into 300. Well, I had to do some figuring on this one. I thought it was going to be probably pretty big. 10 didn't work. It was too much, so 9 was my guess. So 9 times 2 is 18. Third, 27, 28. So 288. And remember, we do have to regroup. So 3, 2, 0, 10 to 9. 9 minus 8 is 1. 10 minus 8 is 2. Now we need another 0. Bring it on down. So 32 goes into 120. That would be, well, 4 times 30 is 120. That's too big. So 3 times 2 is 6. 3 times 3 is 90 in the tens place. Subtract that with the regrouping. 11 minus 9 is 20. 10 minus 6 is 4. Bring down the next 0. Whew, this is getting long. All right, so, no, it goes down here. So, how many times? I'm thinking, let's see, 7 times 3, no, 8 times 3 is 24. Yeah, so 7 times 3 is 21 with a little bit more. So 7 is 14. Regroup, 21, 22. I know, it's taken a while. So 4, 3, regroup to 10. 3 minus 2 is 1. 10 minus 4 is 6. Bring down the next place value. Whew. 160. So 160. Well, 7 was too big. So let's try 6. 6 times 30 is 18. That's too big. So 5 times 3 is 15 with a little bit extra. So 5 times 10. Ooh, look at that. I can see it coming already. 15, 16, and it's perfect. Whew, good thing I went all the way to my decimals. So this 140 divided by 128 is this number. Let me get my other color. Let's see, purple. 1.09375 times 10 to the second power. Oh, so I could change that two place values. So that's times 10 is two place values, or 2 tens is two place values. So that's 109.375 times bigger. And that was the question we were answering. Took us a while to do the calculation part down here, but that's how many times greater that the sun is. Now, usually we don't have a lot of these decimals. We'll talk about it more. We'll use the about 1 and then we'll round it. So 3 tells us what to do to 9. So we're going to leave the 9. It's closer to the 9. So 109, the sun is 109 times bigger than the Earth's diameter. So their diameters are. So that would be how we use that in scientific notation. Now I have another example. How many times greater is the diameter of the aluminum ion? Now, aluminum ion is really small, so that's times 10 to the negative. You see the negative power? Negative 11. So there's lots of decimals. It's tiny. And that's what scientific notation is great for. Then the diameter of the sun. Wait, that sounded different than the one above. Up here it said how many times greater is the sun? So we went from the Earth to the sun. Now the aluminum ion. So we want to know how many times greater is the aluminum's. It doesn't make sense with it, but how many times bigger is a fraction, right? So I'm thinking this one is a nice 5. I'll think about it as a thinking part with a 5. Over here, close to 15. So let me think, or you know what, I'll do 10 instead. I like 10 better rather than 15. 10 is a nicer number, but works with 5. So how many times bigger? Now, if I went this way from what we did in the example 1, so how many times bigger is the sun than the aluminum ion? That would be times 2, right? So how do we get 2 with 5 and 10? Well, we put the 10 on top and the 5 on the bottom. We don't have to look very far for our numbers. They're right there. So if we're going one direction with scale factor, to go the other direction, we just take the reciprocal. So that 10/5 would simplify to 2 over 1, which would be 1 over 2. So if we used our simpler numbers that we did, now those aren't the true ones, those are just thinking about it to get our thinking in the math, this math part down, and then we're just going to put those numbers in. So going this direction, what it's saying is how many times greater is the aluminum ion than the diameter of the sun? So this way with our thinking numbers, it's like half as times 1/2 greater, which that makes sort of sense. So let's see, we're going to use this one, not the bottom one. The bottom one was the easier thinking, but we're not going to go that direction because then it would be the sun first and then the aluminum ion in the back. So that 5 was on, the bigger number was on the bottom, so that was the 10. So that would be the sun on the bottom this time and the aluminum ion on the top. So I think I'm going to need some space. So I'm going to bring this thinking down here. All right, so times the aluminum, which is already in scientific notation. And then I've got my sun. Now that's not in scientific notation. So I'm going to move it into scientific notation. So 3, 6, 9. So 1.4 times 9 to the positive because it's a bigger number. So, no, 1.4 times 10 to the 9th power. All right, so now I just need to reorganize it. So I'm going to move my times 10 to the 9th power up to the top. So that will be times 10 to the negative 11 times, and then when that 9, positive 9 moves up, it becomes a negative 9 exponent because we moved it from one part of the fraction to the other part. And our fraction, oh, I've got one decimal. So our fraction is 5 over 1.4. So I've got a decimal within my fraction. So I'm going to deal with that over here. Little sideline math. So 5 over 1. So I'll multiply both of those by 10 over 10 to move that decimal. So that would be 50 over 14. Take half of each. So that would be 25 over 7. Oh, okay. So that would be, I'm going to have to do my long division again now. So I'll set that up. 7, 25 goes in the house. I'm dividing by 7. So 7 goes into 25. Oh, put my decimal first. 7 goes into 25 3 times. So 21 minus 4. Bring down the next place value, 0. 7 goes into, there's 42. So 5 would be the next one is 35. Subtract would be 5 left over. Bring the next one down. There's 7. 49. 1. Now, how far do we go? Well, we could go to maybe, usually it's like 3 place values. Some are 2 place values. So we're going to go 2 place values, but we have to go to the third one to see where we round. So we'll bring that one down. 1 times 7 is 10, so we'll have some left over. That's okay. But the 1 tells us what to do with the place value of the second place value. And typically that's either the second or third place values where we go when it continues on. So that tells us to keep the 7 the same. So our answer is 3.57 times 10 to the negative 11 plus negative 9 is negative 20 times bigger. Or I guess we could call it smaller. So, or larger, smaller. So, but what that tells us is our multiplier of the sun diameter to get to the diameter of an aluminum ion. And that has 21 place values. I wouldn't say zeros because it's 19 zeros, but it will be 21. And that's where the scientific notation comes in really handy because we don't have to write them all. We can just, all those zeros, we can just write it in leave it in scientific notation.